Hi, thanks for joining us. The video you're about to watch is a recording of Durham Public School seniors participating in Riverside High School's PLTW engineering program. These seniors are enrolled in a capstone course known as Engineering Design and Development, appropriately referred to as EDD. EDD is a research and development course designed to challenge students with the rigorous tasks of determining and justifying a problem, and then developing and creating a novel yet viable solution. Over the past 4 weeks, these young women and men have worked tirelessly to justify a problem they believe is valid and worth solving. There have been many sleepless nights by both students and their instructor. They began by sorting themselves into teams based on their interest in topic areas of which they individually researched and then presented on during the first 4 days of class. These dedicated students immediately sought out a variety of professionals to spark them along their path to success, writing professional emails to organizations and individuals they deemed most important to their problem, their research, and their goals. Each team has begun to determine who the best people are to support them as mentors and experts. As they researched their markets, they discovered who their competitors are, they determined their stakeholders, and they even polled their consumers and end users. But their tasks did not stop there. They have also developed the technical reports for the first 3 elements and the beginnings of the next 2 elements necessary for their portfolio. And just think, they only have 9 more elements to go. Some teams have gone as far as creating electronic portfolio websites, while others have extensively organized their work in digital storage sites. But all of the teams have taken the time to create a thorough presentation of their first proposal. They have worked around the clock at beginning the design process that will bring their creative solutions to fruition. All of their work will be completed virtually during the 2020 fall semester in the midst of the COVID-19 pandemic. Their tasks and work are unprecedented. For the remainder of the semester, our wonderful students will work towards deciding on the best solution, attempting to develop and create a prototype, and continue presenting in a very similar fashion during milestone proposals like the one you're about to watch. Without further ado, it brings me great pleasure to present to you PEERE Water Solutions and their project proposal.
This is our project proposal for PEERE Water Solutions. I'm Ella. So our problem statement is, in 2017, the World Health Organization, or WHO, and UNICEF stated that at least 2.2 billion people around the world use contaminated drinking water. Having a safe and accessible water supply is an essential factor in public health and the economy, and billions of people are affected by contaminated drinking water. And our target market is people whose access to clean water is not readily available. And we intentionally targeted a wider market because our goal solution, we want to have users for a number of water-related issues. Each of us had experienced some form of water contamination issues and immediately took an interest in the problem. Our team, as a team, the problem we have is we see that it's too big to solve with just one product, but we see it as an opportunity to improve a part of a bigger whole. We did a survey asking people who were willing to take this survey. We asked them questions about clean drinking water and how it affects their daily life. We found that the majority of people that took the survey have used some form of filtration system. Our main goal is to create a handheld product that will filter contaminated water quickly and efficiently. In our market analysis, with our problem being one that is very big, we wanted to focus more on developed regions since it's more attainable to us. And if needed, we could extend to third world countries. Our target market consumers are people who like traveling and camping, and also who just want a quick and easy way to filter their water. The picture in the bottom right are the results of one of our questions of our market survey. The question is, in the past, have you personally used a water filtration system? And the blue is for yes. And as you can see, the majority of the people that took the survey have used some form of water filtration. And our buyers and users include people that struggle with contaminated water. Our buyers also include nonprofit organizations and that can provide resources to developing regions. Our decision matrix, the plan was to come up with 8 problem statements and the work divided evenly so each of us came up with 2, and using the decision matrix, which is the picture in the bottom right, what we wanted. And so after much discussion, we decided to make it more concise and came up with the problem that is this.
So when we were looking at the prior solution attempts, we came up with 5 different criteria for each product. The first one that we wanted to look at was the cost. We wanted to have a product that has a reasonable price, especially for people in low-income areas, so that they are able to afford access to clean water and not just rich people. Our second criteria was durability, which means how long the filter is able to last. So that's because if you use a filter for longer than intended, it can have some harmful repercussions to your health. And then we looked at efficiency, which means how many contaminants the filter actually helps filter. And then we looked also at sustainability, which was mostly if it's recyclable and how easy it is to to recycle it. And then we looked at accessibility, which was how easy it is to get the filter, and also if you needed anything prior for it. So this is a decision matrix for the life straw, and on average it totaled 20.9 points. When we looked at the cost, it averaged 3.4 because it costs around $20 mostly. And then when we looked at the durability, it's able to filter 1,000 gallons of water, which is enough for about 5 years of clean water. So it averaged a total of 4.7 points. And then the efficiency, well, it filters a lot of contaminants that you might find in rivers, such as dirt, sand, and microorganisms. So we rated it a 5 because it filters out everything you need whenever you're on a camping trip. For the sustainability, we rated it an average of 3.8 because while it's able to be recycled, there wasn't much information. It wasn't as transparent through their website or any resources how exactly you can recycle it. Finally, we looked at the accessibility, in which we rated it an average of 4.2. This is because it is available in a lot of stores like REI and also on online websites. And then we also looked at the Brita Long Last filter, which averaged a total of 21.9 points. The average cost for the points is 3.7. That's because it costs $16.99, so basically $17, which is cheaper than the Life Straw. And then for durability, it averaged 3.4 because it's only able to be used for up to 6 months versus 5 years or 1,000 gallons. For efficiency, we rated it an average of 4.8 because it's able to filter out many contaminants such as lead, mercury, iron, fungi, algae, and many other microorganisms. So it averaged a 4.8. For the sustainability, the Long Last filter averaged a total of 5 because you are able to send this used filter to preserve where they can recycle it. And then we also gave the Brita Long Last filter a 5 in terms of accessibility, because our team has seen it in many stores, and also it's available online and it's not as obscure. And then finally, we have the PEERE Advanced Faucet Filtration System, which averaged a total of 12.5 points. The cost averaged a total of 2.2 points. This is because it is the most expensive product that we have researched. The cost was $31, which is a lot more than 20 or say $17. The durability averaged a total of 2 points. This is because you can only use it for 3 months before you have to replace the filter. So this is also a small step backwards compared to 5 years and 6 months. With efficiency, we rated it an average of 3.6. Their website claims to reduce 70 contaminants, such as lead and mercury, and some team members decided to rate it less because of the word reduces, which doesn't necessarily mean that it would eliminate, and you could still have traces of that inside your clean water. For sustainability, we rated it an average of 2.2. This is because, just like the life straw filter, their website isn't transparent enough as to where telling the consumers and the buyers where you could send your used product to be recycled, sorry. And then finally, we rated on average the accessibility as a 3 because it's available through Amazon mostly, and their website is, you could also get it through their website, but right now they're out of stock through their website, so that also played a role in why it got less of a score. Now we look at patents. We have patent JP31646440U, which was submitted in 2010. The abstract says that this filter removes Cryptosporidium protozoa, which is a parasite that can cause respiratory and gastrointestinal illness. They basically have a lot of diarrhea, and then they could also either have a cough or no cough. And it can affect everyone because there's like no immunity towards it. It uses natural filtration media such as gravel and sand, so that was also something that is nice. And then it can easily be backwashed, so you can clean it. And the second patent that we have is patent CN10521784AA, which was submitted in 2015. Its use was to filter seawater, and it used zero carb filtering layers, KDF media filtration layers, ultrafiltration membrane filter devices, and a nanofiltration device. So it was also qualified for health and marine site ship staff in coastal and island families. So you would have technically been able to use it if you were at sea and you needed some water instead of drinking seawater and dehydrating. And it also removes silt, iron rust, and other bacteria and viruses. And then we have patent US 885243-9B2, which was submitted in 2009. And it's basically a straw with hollow fibers that filter contaminants with the filtering membrane wall. And this is actually used in life straws filters. This is their patent.
The way that we determined our design specifications, which include our criteria and constraints, is by looking at our survey that we did, and one of our mentors is also a new product development engineer, and so we used him as an expert to determine the specifications. As you can see in the picture, that was the main information from the survey that we used to determine our specifications, and people who took the survey checked off features that they found necessary for a water filtration system. We have also contacted, they have not responded yet. We have contacted a third world country details expert. So this person lives or has lived in Africa, and so they would have information about what the water problem is there. And we've also contracted LifeStraw as a stakeholder. So these are our design specifications in order of decreasing priority. First one is the solution will filter contaminated drinking water, which can include parasites, bacteria, microplastics, dirt, and sand, cloudiness, and harmful particles. This is the most important because that's the whole purpose of us trying to find a solution to a problem. The second one is the solution will be made out of materials used, or the solution will be made out of materials used in the filter and casing of the solution will either be biodegradable or recyclable and reused. So we looked into finding ways to make our product or solution sustainable. And the plastic that we have decided that we are thinking about using is high density polyethylene, which is just the same type of plastic that we use for milk jugs and things like that. And it's very easily recyclable. And we are still looking into what to use for our filter. Then the solution will be no more than 2 pounds, and the solution will be no more than 12 inches long and at most 5 inches in diameter / width. These two factors are also a priority because they would determine that our product can be portable, which is what we want it to revolve around. And the fifth one is solution will be reusable because no consumer wants to use it once and then throw it away and then buy another one, and also it would produce less trash. The sixth one, the solution will have replacement or exchangeable parts if necessary, and the solution will cost no more than $20 for manufacturing. These design specifications are mainly for reducing the cost for consumers, and then the solution will have easily accessible parts that can be efficiently cleaned. That is for consumers, again, reducing the cost for consumers and how much they have to pay and repay and things like that. So the next one, number 9, solution will have to withstand temperatures of -100 degrees Fahrenheit to 120 degrees Fahrenheit. This is for the purpose of where our product will be used. There are many different regions in the world that would be used, and different type of climates. And the solution will ideally look aesthetically pleasing to a consumer, and the solution will not resemble any existing solutions in terms of design and concept. It will not resemble existing solutions. Those two are not a priority, but they are something that we want to look into so we can make it better we can sell better for the market.
So this is the research done to find out what the product life cycle would be. We looked at the research, how the filter works, like it's an active carbon ion exchange, and then we looked at its end of life cycle. It is either thrown away or shipped to British recycling partners, and we wanted to come up with a product that is more easily recyclable than that. And we also researched its environmental impact. So for technology, we use a Gantt chart to help keep everything organized. This way we can see due dates, when it's open, and then who's working on it and who's contributing. This allows us to stay organized and stay on top of everything. And then conducting market research survey and spreadsheet. This is a survey we gave out to people to find out if there is water filtration problems in their area. We're trying to get this out to as many people as possible to try and figure out where our target market would most likely be. And so far, 33 people have submitted the survey. This is where we started focusing on how the product will look, perform, what it will be made of, and the constraints we'll have on it, as Isha talked about. Some of the ones she said, it can handle hot and cold temperatures, environmental friendly, and can be used multiple times. And these both were put under math because of the decision matrices we used, where we'd add up and decide like which one is best. This is what Romina talked about earlier. And we've already edited the problem statement we came up So since then, so it's always like we're changing.
Our competitors are our top three competitors that we've looked at are LifeStraw, Brita, and PEERE. The LifeStraw is more for outdoor backpacking, outdoor trips, and things like that. And the Brita and PEERE filtration systems are more for household use. And the Brita is more of a portable solution, while the PEERE filtration is more of an install into the faucet. For our marketplace study, people are willing to pay between $10 and $50 according to the survey that we put out. A lot of the buyers will be nonprofit organizations trying to help people in lower areas that need cleaner water. The campers, travelers, and survival purposes are a big part of, or they're more of a portion of what our focus will be. Products will produce filtered, safe drinking water from rivers, lakes, and tap water, as well as wells. This product life cycle is a graphic design that will be general and directed towards the use of HDPE for the outside design and organic biodegradable substances for the filter. Also, billions of people every year use contaminated water, and about 500,000 people die from contaminated water due to human and animal wastes. Anyone have any questions?
And you have about 2.5 minutes for questions.
Anyone have questions in those 2.5 minutes?
Oh, I'll ask the question. Yeah, I mean, this is the first time I've been asked to be a mentor, but this is the first time I've seen anything. And my overall comment is, it looks like I hear a global goal, but what I see you're really talking about is a individual system, not a community system. So how are you going to solve a global problem? Or do you want to just change your goal is to have an individual system? I mean, disconnect.
Yeah, I understand what you're saying, Dr. Hubert, but I think what we were aiming for was that so people buy their own product, and then as we get some momentum and we have profits, for every, let's say, like, we would be able to send products to developing countries, regions and countries in the world, in order to help them also and not just target the who we're targeting right now.
I think it's somewhere in between. Right now, it does look like more of an individual product, but with some effort put into it, it can definitely be made into more of a community system. That just takes time and a lot of working with the communities.
Well, does Durham have clean water?
For the most part, but there are most definitely areas that definitely have
Okay,
dirty
well, why does it have clean water? Because they have filtration systems already.
Right. Put in place in the ground in the community. And I think for those places that don't have that, this would be a good small scale option to start with.
So if I'm live in a village in Africa and I got dirty water, how much water does my community need in a day?
Well, I think that's where it comes to the individual part, where the whole community, of course, needs the clean water, but as an individual, you can clean your own water with this, and you can, since it isn't really a commodity there, you can go to the river, you can get that big bucket of water, and then while you have it, where you're residing in your village in Africa, wherever part of Africa that might be, you can clean that own water that you got with your individual product.
Okay, excellent, guys. That brings us to the end of your presentation. We have reached 9:37, and we did start 2 minutes late, so this is where I'm going to have to bring it back over to the next team to present. I do want to point out, as they're pulling up their presentation and sharing it with us, a couple of things that I noticed. So you have some pretty interesting patents there, and I think in response to one of those global concerns that Dr. Huber was pointing out, you pulled one up that was on filtering seawater, which is important for your problem if it is global, but if it's not, if it is more local or something that doesn't necessarily need seawater, maybe that's something to look at. I also want to point out that I thought it was really cool you guys brought up HDPE, as that is very much so what we use for those milk jugs when they're made out of plastic. But also, if you didn't know, that's what we used for those bathroom passes that we made at the school for that particular reason, that they're really good plastics to use in that case.